So in this video we are going to compare the N-channel MOSFET and P-channel MOSFETs. So let us discuss them by their basic structure. So the NMOS has a P-type substrate in which N plus regions are going to act as source and drain, and the channel is absent. If we apply some positive VGS to NMOS, what will happen? That will attract the minority carrier of the P-type material, that is electrons, so that electrons will be accumulating near the SiO2 layer and holes will be moved away from the SiO2 layer. So these electrons are going to form the inversion layer and that will form the induced channel. So if VGS is greater than VT, that is the threshold voltage, then the inversion layer will be formed due to the minority carriers, that is electrons, of the P-type substrate. And if we connect some positive voltage to the VDS, then the current will start flowing. Whereas in case of PMOS, we have N-type substrate which has majority carriers as electron and minority carriers as holes. So the majority carrier will be moving away from the junction if negative VGS is applied. So the electrons will be forced to move away from the SiO2 layer and the holes will be attracted towards the SiO2 layer. So the holes will be accumulating near the SiO2 layer, that will form some inversion layer, and due to that the channel is induced. So if we apply some negative VDS to the PMOS, that will make the current to flow, that is because of this induced channel. So what we have seen till now in NMOS, the substrate is P-type which has majority as holes and minority of electrons. Whereas in case of PMOS, the substrate is N-type and that will contain majority of electron and minority of holes. So if we apply positive VGS, these minority carrier electrons will be accumulating near the SiO2 layer. So inversion layer is formed due to electrons. So the VGS should be positive and it should be greater than the threshold voltage, that is VT. So in this case we have VGS is positive and VT is also positive, that is the threshold voltage is also positive for the NMOS. Whereas in case of PMOS, if we apply negative VGS, that will create the inversion layer due to holes, because holes will be attracted by this negative polarity and that will form the inversion layer and hence current will start flowing. So the VGS in this case will be negative and the threshold voltage is negative for the PMOS. So that is the main point that we have, the threshold voltage is positive for NMOS, whereas in case of PMOS it is negative. Let us now consider when we operate the NMOS in triode region, the condition is that VDS should be less than VGS minus VT, and to operate it in the saturation region, the VDS should be greater than or equals to VGS minus VT. These are the relation that we have for the NMOS. Whereas in case of PMOS, the triode region will be when the VDS applied is greater than VGS minus VT, and we are considering only magnitude of VT. Similarly, in case of saturation, the VDS should be less than or equals to VGS minus VT. We are considering the magnitude only. So these are the magnitudes that we are comparing. Okay, this is not a magnitude. That will be the equation, that will be with the sign. Okay, so these are the condition, and you can see the sign is reversed because the polarity of the voltage is going to be reversed, because VGS is positive VT is positive and VDS is positive. Whereas in case of PMOS, the VGS is negative, VT is also negative, and VDS that we are going to apply is also negative. So let us consider the transfer characteristic of NMOS. So in transfer characteristic, if we plot the graph between VGS and ID, then ID current will be initially 0 up to some critical point, that is threshold voltage, and if increased voltage VGS above VT, then current will increase. Similarly, in case of PMOS, what will happen? The drain current and VGS graph will be known as transfer characteristic. The current will be initially 0, and if VGS is greater than VT in magnitude, then the current will start flowing. So you can see the transfer characteristic is going to be exactly mirror image of each other. So